height, female distributed normally. Oh, they are quite tall. The average itself is 1.74. Standard deviation 12.3 centimeter. Earlier it was meter, now it's centimeter. Let's convert first. 1 meter is 100 centimeter, so you're going to get 0.123 meter. Now let's look for probability where the girls are. Oh, this is really tall, 1.71 to 1.8 meter. So I'm going to define my height as x. So x is between 1.71 1.8. It won't affect if you put a equal here, but why do more when the previous was easier? You standardize as usual. One part is negative, the other one is positive. Negative 0.244, 4 digit. .488. So now how to find this probability? Middle part, it's a 0, it's a z, negative, and 488. We want to find this area. So whenever I get two values like that, what I will do is I will just find for one part, and then I will find for the other part, and then I will add the probability. It's quite simple if I do it that way. So what is my thinking process? First I just take 0.488, and then I find all of that. I go and minus my 0.5. If I take everything and minus 0.5, then I can get what is this. So let's read first. For this z value, what is my p value? .48. .6873. So this part is just you minus 1.5 from that. 1873. Keep this. Let's go and find the other one. So to find the other one, what is our thought process? Make it positive, the z value. How? 0.244. The 0 is going to be here. So your aim is this portion, right? So go and read for 0.244 z value. Tell me what you will get for your probability first. So when you read, you will cover everything. Yeah, you will cover until this part, then you minus 0.5 to that. 244. 5963, and when you minus, this part is going to be 0.0963, which is similar to this part that we have drawn earlier. Now let's add 1873 plus this. Now the part B. So what you're doing, earlier it was only about one female. Now 3 randomly selected female, and all of them are having height 1.71 to 1.8. You select 3 female and all of them are also in that height. Let's say this is my female 1, female 2, female 3. Their height ranges from 1.71 to 1.8. So you can choose to do this in a binomial way or just do thinking process. The thinking process is what's her probability now? 2836. Same applies to this and also this female. So you multiply or you just cube your value. 0.0228. Part C, I think you should be able to do this. You are having 50 randomly selected female and exactly 15 are having height within the given range. So which 15? Is it the first 15 or the last 15 or random 15? Of course it is a random 15, so juggling is important. 50 choose 15. The p value is 2836 power 15. When you do 1 minus 7164, your q value power 50 minus 15, which is 35. Do you think your calculator will be able to handle such a big value? Let's check. Yes, it still caters. So what is one question that you have to ask? How if this value gets bigger? How if that value is 9,000 people? It's very rarely we only study 50 females, right? Maybe my survey has about 900 respondents. So how will we cater this issue? Will we be still doing binomial distribution? You can, but it will be tedious. Your calculator won't be able to solve it for you. So this is tomorrow's lesson where you will learn how to do normal approximation to the binomial distribution.